In this video, we're going to look at solving inequalities involving exponentials and specifically a focus on what happens to the inequality symbol because there's always a lot of confusion with that. So we've got our inequality here that we're going to solve. Okay, and clearly it's exponential because if you look here, we have 0.8 to the power of n, so n our unknown is in the power, so it's exponential. Now the first thing we're going to do is we're going to rearrange the inequality to get the exponential term on its own. Okay, so I'm going to subtract 1 from both sides, so I'd get negative 0.8 to the power of n is greater than, and then it would be negative 0.1. Now, I don't like the fact that there's this negative sign in front of the 0.8 to the power of n. So I'm going to multiply by negative 1 on both sides. Okay, so we get positive 0.8 to the power of n. And we get positive 0.1. And because we multiplied by a negative, I'm going to have to flip my inequality symbol. So it's going to become a smaller than like that. Now that we got the exponential on its own, it's time to make use of logarithms. Now, what a lot of people would do is they'd see the base is 0.8 and think, okay, we're going to use log base 0.8. And the other side is a 0.1, so that's going to go in our log function. And then our power n would go on the other side. And then they'd be confused as to what they need to do with the inequality symbol. Now, in order to understand what we're going to do with the inequality symbol, I'm actually going to approach this in a slightly different way, okay? I'm not going to do it like I was writing out here, so I'm just going to take that off. What I'm going to start by doing is by taking logarithms of both sides, okay? And let's just pick a base to do this with. Now, technically, you could answer the question in any base. However, we're going to investigate a few different bases and see what happens. So let's do log base 10. So I'm going to write log base 10 of 0.8 to the power of n, and then log base 10 of 0.1. But even after I've done that, there's still a question mark as to which way the inequality symbol should go. Now, in order to investigate this, we're going to look at some graphs. Okay, I want to look at the graph of y equals log base 10 of x. So I'm going to draw my axis. And maybe you're unsure as to what this graph should look like. So let's go with a graph you're more likely to be familiar with, which is y equals 10 to the power of x. So I picked 10 because it's the base here, okay? And the relationship between this graph and this graph is that they are the inverses of each other. Okay, so we're going to make use of that to draw the graphs. So for y equals 10 to the power of x, hopefully you're familiar. Given our exponential base is greater than 1, this represents exponential growth. So the graph would look like that. Okay. So we got our y-axis and our x-axis. Our y-intercept should be 1, but I'm just going to leave that off the graph for now as we don't really need it. So let's now have a consideration as to what y equals log base 10 of x is going to be. Now, the relationship between the graphs of inverses are that they are reflections in y equals x. So I'm just going to note that here, reflection in y equals x. Okay, so now I can do a drawing of my logarithm graph, and if I was to reflect this initial curve in y equals x, I would get this here like that. That would be my graph. Now, what I'm going to consider is if I take two x coordinates on my graph, so let's go, for example, let's go for this x coordinate here, and we're going to go for this one here. Okay, so we'll call this x1, and this is going to be x2. And we're also going to look at the y coordinates. Okay, so the y coordinate here, if we go along, is y1. So essentially, this is what we get out when I do log base 10 of x1. Okay, that's what the y coordinate represents. And now let's do the other y coordinate, okay, and we are going to call it y2 like that. Now, I just want to think about the relationships between the x's and the y's here. So x2 is further to the right on the x-axis, so therefore x2 is greater than x1. And if you look at our y coordinates, well, the y2 is higher up, so therefore y2 is greater than y1. Okay, so in log base 10, if one x coordinate is higher than the other, so what you're substituting into the log, then the output of the higher x coordinate will remain higher than the output of the smaller x coordinate. And this will apply regardless of what x values you pick, because if you look at our curve here, it's what we would call always increasing. That curve is always going upwards as we increase our x coordinate. So a higher x coordinate is going to get us a higher value out of our logarithm. So if we go back to my inequality, okay, and look here, the 0.1 on the right-hand side is meant to be greater than the left-hand side. So therefore, the log base 10 of 0.1 should be greater than the log base 10 of the other side of the equation. So in this circumstance, the inequality symbol has not reversed, okay, it's not flipped. Now let's keep going with the solving. Now I don't like the fact that n is in a power here, so therefore I'm going to use the power rule to bring it to the front. So it's going to become n log base 10 of 0.8, like that, and that is smaller than log base 10 of 0.1. Now the n here is being multiplied by the log base 10 of 0.8, so I need to divide by log base 10 of 0.8. So I'm just going to write that down here. And we're doing it on both sides, of course. So on the left-hand side, the log base 10 of 0.8 is going to be cancelled out, so we're just left with n. And then on the right-hand side, we're going to get log base 10 of 0.1 divided by log base 10 of 0.8. Okay, now the question is, which way does our inequality symbol go? Well, we've divided, so the question is this value here that we divided by, is it positive or is it negative? If it's positive, the inequality sign isn't going to change around. If it's negative, of course, the inequality sign is going to flip. So let's put log base 10 of 0.8 in the calculator and see exactly what I get. Okay, so when I put it in, this comes out as negative 0.0970. Okay, so it's negative. So therefore, we need to flip our inequality symbol. So it's going to go from a less than to a greater than, like that. Okay, so that would be the solution of our inequality there. You could pop this fraction in the calculator to get a decimal if you want, but I'll leave it like that. Now let's just consider a different way of doing things. So I want to go back to this line of working here. So I'm going to write that back down over here. So let's say 0.8 to the power of n is smaller than 0.1. Okay, so I used log base 10 before. Let's use a different base. Okay, let's go for a base smaller than 1, and you'll see why I'm going to do that in a second. Okay, let's go with log base 0.5. Okay, and then I'm going to take that logarithm of both sides, so I put 0.8 to the power of n, and then log base 0.5 of 0.1, like that. Okay, and then we have to ask ourselves again, which way is the inequality symbol going to go? Now, in this scenario, what I've changed up is we now have the base being smaller than 1. So that's going to be important for my graphs that I'm going to end up drawing out. Okay, so at the bottom here, I am going to end up drawing the graph of y equals log base 0.5 of x. Okay, so that's what I'm going to draw at the bottom. However, in order to understand how this is going to look, what I'm first going to draw is y equals 0.5 to the power of x, because that is the inverse function of the other graph. Okay, so once I've got this first one drawn, we can reflect in y equals x. So now that the base of my exponential is smaller than 1, we've got exponential decay. So therefore, our graph is going to look like this. Then our graph of y equals log base 0.5 of x is going to be a reflection in y equals x of that. So it's going to end up looking something a bit like this. Okay, so that would be my graph. Now, just like before, what I'm going to do is I'm going to take a couple of x coordinates on my graph. Okay, so let's go with this x coordinate here, which I'll call x1, and then this one here, which I'll call x2. Okay, and then just like before, I'm going to label the y coordinates on. So I'm going to have this one here, which is going to be y1, and then this one here, which is going to be y2. And let's just compare our x and our y coordinates together. Okay, so our x coordinates increase go to the right, so therefore x2 is greater than x1. And then our y coordinates, which is what we get out when we put those x coordinates into our logarithm, well, our y coordinates increase going upwards, so therefore y1 is greater than y2. So what you can see is that greater x coordinate, x2, has actually given us the smaller value out of our logarithm. Okay, and the reason this happens is because our logarithm curve for a base smaller than 1, okay, if we look here, is always decreasing. As the x-coordinate increases, so to the right, the x-coordinate's increasing, the y-coordinate is always decreasing, going downwards. Therefore, the greater x-coordinate is actually going to give us the smaller output out of our logarithm. So if we go back to our inequality, okay, it was the 0.8 to the power of n, which was the smaller value. Okay, so that's going to give us the greater value out of our logarithm. So the greater than symbol is going to be facing that way. Okay, so we've got our inequality set up now after taking logs on both sides. So let's get the n out of the power just like before. So it'd be n multiplied by log 0.5 of 0.8. And then that's going to be greater than log of 0.5 of 0.1. Like that. Now the n is being multiplied by this here, so that is what we are going to divide by on both sides. So we're going to divide by log 0.5 of 0.8 on both sides. And then that's going to cancel out this on the left hand side, so we're just left with n. And then on the right hand side, we've got this here, the log 0.5 of 0.1. And that is going to be divided by log of 0.5 of 0.8. So now we have to decide which way our inequality symbol is going to go. And to determine that, we have to consider what we divided by. So we divided by log base 0.5 of 0.8. What I'm going to do is I'm going to stick that into the calculator. And we need to see, is it positive or is it negative? Because that's what's going to decide which way our symbol goes. So I put it in the calculator and I've got 0.322. So importantly, that is positive this time. Okay, there's the value greater than 0. So therefore, the inequality symbol would not flip. It's going to remain a greater than facing to the left. Okay, and then that would be the solution of our inequality. Now, what we could do is put both of our solutions into the calculator just to double check we get the same value. So let's just do that now. And for this one down here, I get 10.3. And then for the one at the top, I also get 10.3. Okay, so in both instances, we've got the exact same solution using different log bases. But as you can see, some of the things I've done in my steps have been different. Okay, so the base you use is quite important. So hopefully that's given you a better idea of how you solve inequalities involving exponentials and which way the inequality symbol should be facing.